Welcome back to the class on electrical vehicles and hybrid electrical vehicles. In this lecture, we are going to discuss about the basic concepts of the modern electric vehicle. All electrical manufacturers and designers always think about the size of the car will be very less and the performance will be good. They are taking into consideration of whatever the components which are placed on the chassis of a EV, those are not going to touch the legroom of the automobile. So whenever you are saying the electrical vehicle, there are a lot of electrical equipment is there. During the operation of the electrical vehicle, it should not occur the internal short circuit as well as the external short circuit. The various types of arrangements or configurations used by the EV manufacturers and designers, nothing but how we can connect the different components in EV such that the performance of the EV should be very high. Size of the EV also will be the compact. Modern electrical vehicle has a three subsystems mainly. Electrical propulsion subsystem. Second one is the energy source subsystem. Third one is the auxiliary subsystem. This is the overall block diagram of the electrical vehicle. This is the wheel 1, this is the wheel 2, this is the differential. The electric motor is connected to the differential through the shaft. This is black line is nothing but a mechanical connection. This color of arrow is representing the electrical connection. All these are the electrical connections. This color of arrow is representing the communication system connection. Now the electrical motor is connected mechanically to the differential. Whatever the power is required by the electrical motor, that should be come from the power converter, nothing but a power training converter. Generally nowadays in the electrical motor we are using only the AC motor, so whatever the power requirement at this point is the AC voltage, that should be given by the power converter. Input to the power converter is the energy storage device, that is the battery. So whatever the source which is available here, that will be converted into the AC voltage with the help of electronic controller. The main function of this electronic controller is that it will generate a pulses to the power converter so that the DC voltage will be converted into the AC voltage. The input for the electronic controller is the brakes and accelerator. These two will be operated by the driver. This is nothing but a electrical propulsion system. So whenever we are saying the propulsion means how much power we are going to give between the wheels of a vehicle so that vehicle will be running very smoothly on the roadway. Now if we come to the energy management system, it will take and give the information to the energy storage device and refilling unit. Suppose if you use the battery is discharged, that information will be taken from energy management system. It makes sure that after a certain time the battery will be charged. So another function of the energy management system is that it is working along with the electronic controller during the regenerative braking. Whatever the power is coming from the vehicle, that should be stored in a energy storage device. Not only the motor, some other equipments also will be there in electric vehicle. Those electrical equipment requires a electrical power at a different voltage level. That power will be given by the auxiliary power source. This is the temperature control unit. So when you're going to operate the vehicle, the temperature of the system will be increases, taking consideration of this temperature control unit. Power steering unit. This is the steering wheel. The steering wheel is operated by the driver. That signal will come to the power steering unit. Based upon that signal, the remaining system will be work. So in this manner, different components of a modern electric vehicle which are operating. This part is nothing but a energy source subsystem. This part is nothing but auxiliary subsystem. Electrical propulsion subsystem consisting a electronic controller, power converter. Generally the power converter is the three-phase PWM inverter. Electric motor. Whenever we are saying the electrical motor means you can use any type of AC motor, that is depending upon the requirement to the vehicle. Mechanical transmission. So whatever the power is generated in the motor, that should be transmitted to the frontal axle of the wheel through the differential. In modern EVs, they are not using a gearbox, but in some EVs using the single gearbox. Next, driving wheel. All these are coming under the electrical propulsion subsystem. So one more component also coming under this is the braking system. Generally in the EV, the regenerative braking is occurred. Suppose it is not feasible to apply the regenerative braking in EV means, then we are going for the mechanical braking. Energy source subsystem consisting of again three components. One is the energy source. The source may be the battery, fuel cell, ultra capacitor or other. Energy refilling unit. If you take the battery, if the battery is discharged, then you have to recharge the battery. Energy management system. Already we know that the energy management system is work along the electronic circuit. Make sure that the regenerative braking will be occurs properly in the vehicle. Not only that, it also taking into consideration of the charging state of the battery. Auxiliary subsystem is consisting of three components. One is the power steering unit. Second one is the temperature control unit. Third one is the auxiliary power supply. Now in modern electrical drive, we are not used any gearbox, but some modern electrical drives they use the gearbox also. Now we are going to see what is meant by gear. Gear is nothing but it is a mechanical device which transfers a power from one part to the another part at a increasing torque with a decreasing speed. It is very simple construction. It has a two wheels. The outer periphery is consisting of teeth, but for simplicity we are not showing in this diagram. This is the one wheel where we are giving a power input to the wheel. This is the bigger wheel where the radius of the wheel is very high when compared to the input wheel. At this wheel we are giving a power input that will be transmitted to the long radius wheel, so that the mechanical power will be transmitting from this wheel to this wheel. If you neglecting the loss occurs in a gearbox, then whatever the power we are giving to the input of a gear, the same amount of power we can take in from the output of as a gear. This is the torque which is applied on the input side. This is the angular speed of a wheel direction. This is the radius of a gear. When the wheel is rotating in this manner, whatever the output wheel is connected to the input wheel, that will be rotated in a opposite direction. This is the angular velocity of a output wheel. This is the torque developed at a output wheel. So when you are transmitting a power one gear to the another gear, the power is the constant. So we can increase the torque by decreasing the speed. Suppose if you are decreasing the torque, the speed at output will be increases. The gearbox is not used to increase the shaft speed of a electric motor, because high torque motor is unnecessarily designed, where the size of the motor is highly depending upon the torque output. But if you take the gear ratio, we know the relation between the linear velocity to the angular velocity. Linear velocity V equal to omega into R. The linear velocity at the point of contact is equal of a two wheels. Then at input side, the angular velocity of this wheel into radius of this wheel equal to angular velocity of the output wheel into radius of this wheel, that is equal to small v, where small v is nothing but a linear velocity. If we find the ratio between the angular velocity of output to the angular velocity of input, then it is equal to the radius of input wheel to the radius of output. If we neglect the losses in a gearbox, then input power equal to the output power. So whatever the torque is applied at input, that is Tn into omega in equal to T output into omega output. If we find the ratio between the input torque to the output torque, that is equal to the angular velocity of a wheel at output divided by the angular velocity of wheel at a input, that is equal to the radius of a input wheel to the radius of a output wheel. This is nothing but a gear ratio. So from this expression we can say very easily that whatever the torque is applied at an input, now what is the torque we are taking from the output, that is directly proportional to the radius of the wheel. Automobile differential, one of the very important component in EVs as well as IC engine vehicles also. This is placed on the frontal axle of the vehicle. This is wheel 1, this is the wheel 2, this is the engine, this is the drive shaft. This drive shaft is directly connected to the drive pinion. Nothing but this is the one gear which is rotating in this direction. The outer periphery is teeth are there, that we are not shown for simplicity only. Motor is giving the power to the pinion drive. The bare wheel drive will be rotating. The bare wheel drive is in this manner. So when it is rotating in this direction, the bare wheel drive will be rotating in this direction. Bare wheel is nothing but the gear which is operating with some angle with another gear. So it is operating 90 degrees with the drive pinion wheel. Bare wheel drive is connected to the axle of the one wheel. It is also connected to the differential case. The shaft also connected to the differential. This is one more gear. This is also one more gear. From this gear, the second wheel is connected. In the differential, this is the one gear, this is another gear. Between these two gears, one more gear will be operating, that is the differential pinion. So when this differential pinion will be coming to the picture means, as long as the two wheels are rotating in a same velocity, it is a fixed between these two gears. So whatever the power is given by the engine, that will be transmitted to the two wheels very directly. Suppose if the driver is taking some turning, in that case the distance traveled by this wheel will be higher when compared to this wheel. That is depending upon how the driver is taking the turning. Suppose if the driver is taking the turning in this direction, the distance traveled by this wheel will be more and compared to this wheel. When the vehicle is going in the turnings and all, the differential pinion, nothing but this gear will be providing the different velocity to the wheel, so that the two wheels will be taking a turning. This type of gear is used in automobile differential is known as a planetary gear, where set of gear trains operate in coordinate manner. In case of EV, generally we are using a regenerative braking. Sometimes we are not able to adopt the regenerative braking in EVs. By the time we are going for the mechanical braking. Whenever you are saying the mechanical braking, because of the friction only, the speed of a wheel will be decreases. Here there are two types of braking systems are there. One is drum brake or internal expanding brake. The drum is connected to the hub of the shaft of a vehicle. As the wheel is rotating, this drum also will be rotating. Inside of the drum, this is the brake shoe. This is the braking line or braking material. These are nothing but anchor pins. In this manner, the lower side is fixed. So whenever we are providing some force here, these two will be expanded in this manner. When these two brake shoes are expanded in this manner, it go and touches the rotating drum. It will apply the friction on the drum, so that the kinetic speed of a wheel will be decreases. So how much distance these two brake shoes has to move apart, that is depending upon some mechanism that we are calling as a cam. That we can operate it as manually or hydraulically also we can operate it. This total thing will be placed on the back plate. Now when the wheel is rotating, the drum only rotating, this total part is not going to rotate. That is fixed. So whenever the driver applying a brakes means, then this distance will be increases. Once the distance is increases, then the brake shoes will be go and touches the rotating drum. So the speed of wheel will be decreases. So once we withdraw the brakes, again the brake shoes has to come back to the same position. That's why these two are connected with a spring. This is the practical drum brake. See, this is the cam. Generally it is operated with a hydraulic operation. So this is this part is nothing but this one. This is nothing but this brake shoe. This brake shoe, the same type of brake shoe also there, this side also. See, this is the brake line. This is brake shoe. This brake shoe is connected permanently to the back plate. So this is the spring. This is the shaft of a vehicle. Outer drum is there. This drum is connected to the shaft. So whenever the wheel is rotating, this drum only rotating. This is the stationary part. The main disadvantage of the drum brake is that it is placed inside of the wheel. So when you are going to apply the braking, there is a lot of heat will be generated in a drum brakes that will not be dissipated. But the drum brakes generally using for the four-wheelers, disc brake. It is also known as a external contacting brake. See here, this is the disc which is connected to the hub of the shaft of a wheel. This is nothing but a rotating disc. When the wheel is rotating, the disc also will be rotating. The disc will be placed inside of a coupler. This is the coupler. This is connected mechanically to the chassis of a vehicle. This coupler also houses the brake shoes. So suppose if you take this is the disc, this side and this side the brake shoes are there. Those brake shoes will be held by the Kepler, where Kepler is directly connected chassis of a vehicle. When the vehicle is rotating, this disc also will be rotating between the two brakes. As long as the driver is not giving any signal, these brake shoes are not going to touch the disc. Suppose if the driver is given any signal means, then this brake shoes will be going presses the disc so that there is some amount of friction between the brake shoes as well as the disc that will be transmitted to the wheels of a vehicle, so the speed of the vehicle will be decreased. Now how we are going to operate these brake shoes means, which are placed in the Kepler means, that we can operate it manually or in a hydraulic system also. In case of hydraulic system, see here, this is the one piston. Whenever we apply the brake, the piston will be moved in this direction. Again here, this is one cylinder. Within the cylinder, here one piston is there. This is the tube. From this piston to this piston, the total thing will be filled with a liquid. So whenever we are applying the force at this point, that will be transmitted to this piston because of this compressed fluid. So here there is some force we can get it here, that will be go and apply at a brake shoes. So the brake shoes will be pressed on the disc so that there is some amount of friction will be occurs. Because of friction, the speed of the vehicle will be decreases. This arrangement is nothing but a hydraulic operated system. The EV configurations are equipped with the following components: 3-phase AC motor used to provide a tractive force to the EV, and PWM inverter, nothing but a powertronic converter which can give the variable AC voltage as well as a frequency. Fixed gearing system in case of EV, the multiple gearing system that we are using for the IC engine based vehicles. The differential is also the gear system, but this gear system will come to the picture when the vehicle is going to take the corners. And one more thing is the battery. It is very important, also costly. Generally nowadays we are using the lithium ion battery pack. Now classifications of electrical vehicle configurations. How we are going to arrange these components in electrical vehicle so that we can get a different benefits from the electrical vehicle. These configurations are proposed by the manufacturers as well as the designers of a EV. Electrical vehicle configuration is broadly classified into two types. One is the drivetrain arrangement, another one is the power source arrangement. So based upon the drivetrain arrangement, some configurations are proposed. Based upon the power source arrangement also, some configurations are proposed in EVs. That we are going to discuss in the next lecture. Okay, thank you very much. If you have any doubt, ask me directly or ask in the comment box of my YouTube channel, so that always welcome to answer all your questions.